Okay, so now we'll see a demo of how the program works. But for this case, we have to say that it was very hard to be able to run all of these programs at the same time. So these programs are, or these tasks are the real-time FaceTime camera. It's a full HD camera with a MATLAB script that performs image processing, which is matrices operations, plus recording the desktop on real time. So what we had to do is to choose a little square, like a section of the screen, and record that one. So we're gonna see a video over here that shows how the script works. Okay, so now we're gonna see how the script works. It's gonna perform the recognition through both of the algorithms previously discussed, which are through skeletons and through histogram augmented gradients. We gotta remember that it's gonna take some time, especially in the display of the MATLAB images. This is because we're sampling in time all the frames. Because just as what we said, it takes a lot of computations to do all of these tasks at the same time, which is using the camera, running a MATLAB script, and recording this in real time. So we gotta be a little patient. So here we go. And there it is. So we'll start with 5. And there in the left side we can see how it recognizes for both of the algorithms. Now we go to number 4. In this case only the skeleton recognizes it. Number 3. Number 2. Number 1. And fist. And one more time. Number 1, 2, 3, 4, 5, and fist. So this is a simple demonstration of how it works. We can see that in fact skeletonization is a better algorithm for recognition, just as we said before. So this is the demonstration. Thank you. Okay, so we're gonna talk about the results later on, but now let's move on with the dynamic recognition demo. So let's talk about some details first. So just like in writing, there has to be a signal or a symbol that indicates the start and the end of a hand gesture. For example, when we're typing something, when we're writing something, we need a blank space that indicates the end of a word and the start of a new word. So for our case, our approach has been to use a graphical user interface, a simple dialog box that will ask for one dynamic hand sign at the time. Otherwise, it will be really hard to recognize it, because it would be, for example, just like writing without any spaces between the words. It would be really hard to understand. So we have a consequence for this approach, which is the inability to display the real-time video, because 5 frames is equivalent to approximately 1.6 seconds for a 30 frame per second camera. So for this case, MATLAB would only display like static images, so it's not even worth it to display the real-time images. But we're gonna run the script anyway, and we'll see how it works. So let's go to MATLAB, and let's run the dynamic rec video script. So let's start with the can sign. There we have can. Now I. There we go. Now play. There it goes. Now please. So as we can see, there is a dialog box that indicates when to start the next sign. So now let's change the order. can, play, please. One more time for I, can, play. Oh, okay, so we just set it for 10 dynamic hand signs, but there we could easily see that the skeleton algorithm was a better approach. So let's go back to the presentation. Okay, so after the demonstration, we can see that there are some results, for example, the recognition rate and the dependence on the number of frames that we're taking for the training. So this dependence is shown over here. So for the two algorithms for static hand gestures, we have the skeletons and HOG. And we have a graphic that expresses the recognition rate in terms of the number of frames per static gesture at training. So we see that it's pretty much the same value regardless of the number of gestures taken at training. But for skeletons, the performance is a bit above 90%, and for HOG is around 90%. So for static hand gestures, skeletons performs better. But for the dynamic gestures, we have a very clear difference, because for the skeletons we have a recognition rate of 90%, and for the histogram overrated gradients it's just 75%. And here the total number of signs is fixed of 5 per gesture per algorithm. This is pretty much because we cannot increase the number of frames at training, because that would imply the performance of the sign in a very slow motion, and that's not how it would be in real life, in like real world scenarios. So let's go back to this table. We can see that for the skeletons the recognition rate is higher, and this makes sense because if we remember, when we took the sequence for the skeleton's algorithm, we made it position dependent. And this makes sense because it's not the same to perform a certain dynamic sign in the air that to perform it over the body of the person. So it's position dependent. While for HOG, it only takes into account the mean of the orientation of the histogram over its gradients, but this one never takes into account the position per se of the dynamic hand gesture. So that's why for skeletons is a higher recognition rate. Okay, so now we're going to talk about some of the related work previously done, which is the papers that cover some of the relevant and related issues regarding hand gesture recognition. The first one is called Dynamic Hand Gesture Recognition using the skeleton of the hand. The authors are over there, and the recognition rate was between 77% and 100%. Although there are some differences with our system. For example, for the system implemented in this paper, they only had the background with the hand waving there. So it was not allowed to sit in front of the computer and show your face, pretty much. So in that case, the segmentation was a bit easier because you could do just bare hand segmentation as long as you have a high contrast background. So that makes it a little bit easier for the segmentation. This paper also uses the two algorithms, the skeletons and the HOG algorithm, and the conclusions are pretty much the same. The skeletons will be a better approach. And the second paper is called Visual Interpretation of Hand Gestures for Human-Computer Interaction. The authors are over there. And this paper provides a good overview and a good comparison for hand gesture recognition systems. So it's a good paper in terms of covering the basics for the methods and techniques used for hand gesture recognition. And for this case, there was no recognition rate achieved because it was pretty much a comparison paper. And now let's wrap it up with the conclusions. We can see that the skeleton's algorithm performs a better recognition than HOG for both cases, static and dynamic hand gestures. Just as what we saw in the graphics and the live demos, it is better. Also, the skeleton's algorithm for static gestures is position independent, but for dynamic gestures is position dependent, which makes a lot of sense. We talked about this earlier. For dynamic gestures, it is vital to know where the sign was performed. And for HOG algorithm, we could see that it is faster to compute than the skeleton's algorithm. And this is pretty much straightforward because for the skeleton's algorithm, we're dealing with matrices and with iterative processes, while in HOG, we only have to do a double summation and that's it. So it is faster to compute. The HOG algorithm does not perform well for dynamic gestures. We already talked about this because it is not position dependent. So that is one of its weaknesses. And finally, the optimal system that we would implement, or that we would try to make a prototype out of it, would be a system that uses histogram overrated gradients for static gestures and skeletons for dynamic gestures. In this way, we could take the best from the both algorithms in terms of the classification of the hand gestures. And that would be all. I hope that you enjoyed the presentation. Thank you very much.